We've already discussed the observational setting quite a bit when discussing causal inference, but here we're going to do it more explicitly and think about it more as a study design. This is a causal diagram of an observational cohort study. E is some exposure of choice of participants. There's no random component allocating individuals to different exposures. Z is a set of confounders that we have measured, which are related to the exposure, which cause the exposure, and also cause the disease or outcome. U are also confounders, but they're unmeasured in this case, and they also affect the exposure or the choice of exposure and the outcome. This is measured at follow-up, and crucially, the association between E and D, which we might find, is confounded by these two, or there could be multiple. And so differences in outcome between different exposure groups can't really be called causal because we have confounding and we need to close the backdoor paths. In a well-designed and well-executed randomized trial, we will have superior internal validity because observational studies may be challenged by confounding, among other things. However, a well-designed and well-executed observational study, and may I add, a well-analyzed observational study, will have a stronger case for generalization because participants have chosen exposure on their own. In contrast to a randomized controlled trial, participants are free to select exposure, and so the sample is more like the target population, what the target population would do in a natural setting. Not being randomized also reduces study participant effects. There's value in blinding research personnel and analysts, but it is sometimes impossible to blind participants, especially if they choose treatment themselves or choose exposure themselves. We like to think of cohort studies as either prospective or retrospective, but sometimes the two aren't very discriminating, so there are variations within them. In a prospective study, you observe participants' choice of exposure and study the outcome in contrast. The key is that you ask questions before the fact. So the prospective nature really follows the researcher asking the questions. You decide on a set of questions you want to have the answer to, and you set up a study, you start collecting a cohort of participants, and you follow them over time. If risk is of interest, then obviously participants need to be at risk and not yet have the outcome. So you can't study conditions connected to pregnancy among men, because that's not going to happen. And you can't study the risk of becoming a smoker among smokers, for instance. So those things need to be considered if you're considering incidence or risk. A retrospective study, on the other hand, is a study of a group of individuals who were exposed differently in the past and compare their current status. It's similar to a prospective study, but the data has already at least partially been collected. And the outcome may be different than the one that was intended in the prospective study. So you collect data on the outcome of interest among participants from a cohort where the data already exists, or you could use participants from a cohort and measure new outcomes among them. If exposures are of interest that were not recorded when when the prospective cohort study was created, then interviews and databases may be searched, but they are obviously very much subject to recall bias. If you have a cohort and you want to ask them, well, how was your physical activity 10 years ago? Or how many cigarettes did you smoke per week 15 years ago? That is obviously a biased measure because it's hard to remember. It's a lot quicker than a prospective study because in some cases you already have all the data. You don't have to wait for it. But it's subject to bias and also subject to dredging in the sense that you can go through registers all day long and you're going to find interesting stuff, but it's probably just going to be by chance. And that's usually referred to as dredging. Here are two examples of a retrospective study and a prospective study. In this case, it was a retrospective study with both exposure and outcome already measured. So there wasn't really a risk of going back and doing interviews again. There wasn't a risk of a recall bias in that sense. But the question asked was after the fact. So there's sort of a risk for dredging in that sense. But it had a prospectively registered analysis plan. So there was an analysis plan that had been registered before data was looked at. And the study, or the retrospective cohort study in this case, was looking at body mass index and gestational weight gain in migrant women by birth regions compared with Swedish-born women. And in this register, the migration status and the birth country of the women in the registry was already recorded, as was gestational weight gain and body mass index. So there was no new data required for collection in this case. But it's still retrospective in the sense that it's something that was studied after the fact. Here is an example of a prospective study. There was a set of core questions proposed. There was a plan for follow-up via annual monitoring of the registries and questionnaires at set intervals. And this is the Swedish Cardiopulmonary Bioimage Study, or SCAPIS as many know it. And in the protocol, they define the research questions of interest, and they define how the cohort is going to be initiated, who can be included, etc., etc. And this is then a prospective study because a set of questions were proposed, and then data collections was started, and then we're going to collect follow-up over time.